Please remember, the views expressed on Albertans in Space by our guests and host alike are opinions and do not represent the entire industry as a whole. Our podcast serves only as a platform, and all topics discussed are primarily for educational purposes only. Welcome to Albertans in Space, the series where we talk to Albertans making waves in the local and global space industry. Today's episode, Building from the Regolith Up, we are joined by CEO and founder of Space Copy, Madison Feehan, as we discuss how her award-winning in-situ logistics and additive manufacturing company, Space Copy, is developing 3D printing technologies to support infrastructure development in extreme environments on Earth and in space. I'm your host, Zach Trolley.
And I'm the co-host and solar sister, Megan Westelmajor. Hey, Zach,
yes.
Why was Sylvester Stallone invited to float in the asteroid belt?
I have no idea.
Because he was a rocky body.
Okay, I'll give it to you. Albertans in Space is filmed in the city of Calgary on Treaty 7 territory. This land, traditionally called Mohkinstsis, belongs to many nations and peoples who make their home here. We honor the traditions taught to us by our elders to acknowledge the generosity of Mother Earth and to take care of our land as humanity expands to new worlds. Speaking of belts, I heard you like Orion's belt.
Oh, God. Are you going to make fun of me for getting it wrong last season?
No. Everybody makes mistakes. It is very prominent and recognizable, but yes, Orion's belt is an asterism inside the constellation Orion.
What's the difference between an asterism and a constellation?
So an asterism is a group of stars in the sky. They're typically smaller than constellations, the most famous being the Big Dipper, which is part of the constellation Ursa Major. The ladle stars that we call the Big Dipper are the brightest part of the Bear constellation, and it's hard to see in the city with the amount of light pollution. So head on over to Rothey Observatory just south of Calgary to see it in its full glory.
One of the coolest things I've heard about Orion's belt is that there is a theory that the Egyptians used it to construct the pyramids.
The Egyptian pyramids do align with the cardinal direction, somewhat mirror Orion's belt. And while the Egyptians tracked the night sky closely in order to make decisions where to plant crops and when to harvest, it's still debatable whether the three pyramids of Giza line up with the three stars of Orion's belt, or any stars for that matter.
Nonetheless, they're pretty incredible structures that are super unique in their construction for our early architects. What do you believe? How were the pyramids built? Aliens?
Aliens? No, it wasn't aliens. Humans used the power of water to build them. The Nile River famously floods, so the Egyptians were able to make use of that water as a level, making sure each section of the pyramids were perfectly flat, allowing them to stack up stones onto the impressive temples that are still standing today.
How about Stonehenge? I've been there, and it's super cool. What are its connections to the stars?
So not stars, but star. Stonehenge is built to allow the sun to shine right down the middle at solstice, creating a unique visual experience twice a year. But it's just not ancient cultures that do this. The same thing happens in the buildings of New York. Twice a year, the sun rises aligned perfectly with the streets, creating amazing visuals.
I was today years old when I just found that out.
There you go.
We've come super far with technology and science, but when I think about how humans were able to construct structures like the pyramids 4,500 years ago, it's mind-blowing. Going from hand tools, hammers, water-based pulley systems, and chisels to cranes and steel, robotics, technology, AI. It's incredible.
And now onto something even more impressive. Humanity is exploring the use of 3D printing for building construction off-planet and here on Earth. Our guest today is Madison Feehan, CEO of Space Copy, who can tell us all about it.
Born in Edmonton, Alberta, Madison C. Feehan was only in grade 9 when she came up with her first conceptual design for a 3-dimensional printer for space use. Her innovative idea led the bright student into participating in a NASA-led competition. Although she didn't win, it didn't stop her from pitching her forward-thinking ideas to NASA. Her drive and efforts would pay off. At just 16 years old, NASA would reach out and offer her an opportunity of a lifetime. Madison would go on to work for NASA for the next 5 years, eventually founding her company Space Copy in 2022. Feehan is an early career professional with a background in advanced lunar instrument development for NASA's planetary science, heliophysics, and astrophysics. She also has a background in commerce, along with a Harvard Business School certification in entrepreneurship and innovation, and she continues to pursue studies in international business. As the CEO and leader of Space Copy, Madison drives groundbreaking initiatives that foster innovative space technology and accessibility for STEM education. She serves as the G100 Region Chair of Space Technology and Aviation for the province of Alberta and the chair of the Lunar Chamber of Commerce. Her passion and commitment to shaping foreign policies for small business and STEM throughout volunteer work and consortiums, including United Nations, Lifeboat Foundation, and National Small Business Association, is inspiring and commendable. In 2021, she was awarded the winner of the Edmonton Public School Board Division Awards for Career and Life Pathway and Math and Science Technologies. In 2022, she was a data analyst and citizen scientist image analyst for the European Space Agency CERN and Virgo project. Madison is affiliated with over a dozen associations and societies, including Women in Aerospace Canada, the American Institute of Aeronautics and Astronautics, and NASA's Lunar Surface Innovation Consortium, led by the Johns Hopkins University Applied Physics Laboratory. Did I just black out?
That is a lot. That is a lot happening there.
Impressive is an understatement. What were you doing at 21 years old?
That is the topic for different podcasts. So let's stick to our topic at hand and let's bring on Madison. So Madison, thank you very much for coming to Albertans in Space. We are so excited to talk to you today.
Really happy to be here. Thank you so much.
Can you tell us a little bit about what Space Copy is and what the main goal of your company is?
Yeah, absolutely. So I like to classify us as in situ logistics and additive manufacturing for extreme environments on Earth and space. But put more simply, that we are a 3D printing company that specializes in creating infrastructure from locally sourced materials, things like scrap metal, soil, sand, in the case of space, lunar regolith or the moon soil that you find on the ground. And we convert that into things that astronauts, military and everyday civilians that they need in order to get the job done in really, really extreme environments.
So that is very high tech. Where did your interest in space come from? What is your origin story?
Yeah, absolutely. It is super high tech. I love high tech stuff, though. I've been in this industry for about 8 years now. My initial interest came combining actually art and science. I was working on a CAD modeled project for 3D printed houses on Mars back in 2017, and I had submitted that through the Science Art Exchange, which was a non-for-profit division of NASA Johnson Space Center. The program director of that said, you got really great technology concepts. You have an eye and a vision for aerospace. Why don't you try applying that technology directly to NASA themselves? Which I did, and it was fully rejected on the basis that it was too much of an elementary concept. Maybe I was a little bit too young to be playing in that ecosystem, but they did keep my name on file and circle back with me a couple years later and offered me a job. So I think I did something right. I had the privilege of working for the NASA administration for close to 6 years. I worked in fields related to dual-use technology, specifically for planetary science, heliophysics, and astrophysics. So some of the orbital missions that are flying around both Earth, the sun, and some instrumentation that has been sent to the moon and is still in the pipeline. These are all projects that I was really fortunate to work on.
And what is heliophysics?
The study of the sun, essentially. So anything that is related to the inner or outer heliosphere, which is to say the sun, its atmosphere, how those radiation and solar flares affect life here on Earth, how that can interfere with things like telecommunications. It's a really, really wide range of studies, but it is mostly physics and theorem related.
So, when we ask most people this question, they say, oh, I read a book or I had a good science teacher, but your starting is like I was pitching directly to NASA. That's how you got started.
Seriously.
That's impressive.
I was playing in the backyard as in my astronaut suit, wanting to be an astronaut.
Yeah, I was just sitting in a cardboard box pretending I was in a space shuttle when you were just drawing up the plans. Okay. Yeah.
That is super cool. Was that like a dream come true, getting to work with NASA?
Oh, absolutely. My first foray into aerospace was a presentation on not exactly the atmosphere, but like the qualification, the characteristics of the planet Neptune when I was in elementary school. And I had had a very big passion for aerospace ever since then. So having the opportunity to work on a project that was Mars related, I was homeschooled through some of the later years of my education. So I got a lot of freedom to work on STEM and science related projects that I was highly interested in. And then having that applied to NASA and then going through so many different iterations. And one day getting an email that says, hi, we'd like you to work on this project. There's university students developing out instruments that are going to the moon. We're short-staffed. Do you have some time? Of course we have some time over here. Send it over. So yeah, it was a really gratifying experience. And I think what was really poignant for me is that I didn't have field experience. I didn't have an engineering degree. It was not my traditional background. I was very, very young at the time. And I was thrown into an ecosystem where I was learning by force, just by what was happening around me. It was not structured. There was no training. It was wake up one day and figure out what is a CubeSat, figure out what is a sensor payload. And there was so much radical stuff happening every single day that it gave me a really great opportunity to dive into a bunch of different nuances of subject matter.
Well, we're in our 40s and I'm still waiting for that letter to show up. So we just be sitting by the door, just waiting for it to come by.
Oh my God. It seems like this is something you were born to do, which is pretty cool. Tell us a little bit about the tech. Like, I'm actually really curious about how the 3D printing process works. How long does it take to build these machines? How does construction on Earth differ from, I'm sure it differs quite a bit, but like, what are the timelines for building it on like a lunar surface versus a terrestrial one?
This is the Albertans in Space podcast. I'm proud to say that our first 3D printer is right here in Alberta, and it is going to be launched to the Canadian Arctic next year at an analog astronaut test base called FMARS. And we are going to be doing some simulated lunar condition studies in extreme cold environment using Arctic rocks and Arctic soil that has trace mineral properties from an asteroid that impacted in Canada in the 1950s. So with that little tidbit of information, carrying it over to our current development, the tech is extreme. Obviously, if we're talking about ruggedized 3D printers for the moon, it would have to be pretty intensive in order to make it work. There are so many environmental constraints, whether you're working terrestrially or in space. Generally, I characterize that as thermal gradient extremes, so the extreme temperature difference between extreme heat or cold. But further to that, though, there's things like space-based radiation, dust mitigation, and just a whole bunch of different myriads of factors that we have to take into account when we're building this tech. And a lot of that still translates back down to Earth. There's dust, there's extreme cold and extreme heat. How the technology works from a high-level perspective, I break it down into 4 subgroups. The first piece of the system is what we call mixing, or beneficiation, the super tech term for it. Essentially, we are taking raw materials and we are crushing and mixing and breaking them down into small, fine particulate that can be ingested by a 3D printer. So you might start with small boulders or assorted rocks of various shapes, sizes, and colors and mineralogies, and then we break that down into what we refer to as near homogeneous, so pretty much uniform powder material that could be used as feedstock. The second phase of that is what we refer to as feedstock sampling. I'm going to go super tech on you guys and talk about spectroscopy laser beams.
Perfect.
These spectroscopy laser beams, essentially what they're doing is they're built into the hardware of the system. They're scanning and identifying the mineralogy and the chemical composition of whatever you just broke down. So if it's scrap metal, if it's lunar regolith, if it's just regular sand from the desert, it's telling you the differences in constituency so that you can plan ahead onto what kind of process parameters you need to identify. So that, okay, every time you're 3D printing something, if it's titanium or aluminum based, you have the proper melting point. If it's ceramic based, you have the proper hatch spacing. The third, and in my opinion, most fun stage is the actual 3D printing itself. So we have 2 technologies that we're pioneering. One is extrusion-based. So it creates like a slurry of material and it extrudes it out through a nozzle and it builds up objects. I like to think of it as frosting a cake.
Okay.
And then the alternative method that we employ for really, really precise things, especially small parts like precision tools, that's called SLM, or selective laser melting, essentially where you just have a bed of powder and a laser beam and you are carving shapes with that laser into the powder and then wiping a blade over top of it again, then continuing to build and build up further. The extrusion side of things, there's nothing that's relatively simple about 3D printing in space, but it's a lot easier just to build something up as a slurry as opposed to have really fine-tuned mechanical properties as a powder. So that's those 2 processes. Then I'm going to wrap up that phase 4 with AI and autonomy.
Easy.
Yeah, super simple stuff.
Yeah, that's all you got to do.
Edge computing, machine learning algorithms, custom cyber secure systems for ultimate resilience, especially in areas that have been affected by natural disasters, combat, or just general space. I know not everybody on the politics side of space is all that friendly, so we have to take security into account. But we're developing out these custom algorithms and machine learning iterations, these AI agents. We're integrating it into the larger software of our system. So if you can think about this more broadly, material processing and 3D printing and laser beams identifying the chemical composition of lunar soil. Obviously, that's going to require a whole bunch of software to make it happen. And we have one more special iteration into our system. That's a robotic arm that's doing all of your post-processing, your quality assurance, to make all of those systems come together into one large modular unit. It takes a lot of manpower, it takes a lot of willingness to be creative, and it takes a lot of coding. The variation of how long it takes, because I know, Megan, you asked how long does it actually take to assemble a system like this? If we have a contract for one of our tabletop small units, that would take a couple of months to assemble. If you want to do something that's more large scale infrastructure like housing and launch pads, we have a 3D printer located right here in Edmonton that has a 1 cubic meter print capacity. So
Okay.
3 by 3 feet. And that would take you probably about 6 months to fully install and integrate.
Now, in some of those terms, we had, material properties and benefaction. And I remember in season 1, we were talking about ISRU, in situ resource utilization, and some of those terms came up. How important is ISRU to your company strategy?
It is fundamental to our company strategy.
Nailed it.
You cannot have space-based resource extraction, consumption, and manufacturing without talking about ISRU. And that is an area that I have proudly developed subject matter expertise in.
How do you develop subject matter expertise on other planets like that? I mean, have you been to the moon? If you have, please tell me right now. That's something I want to know.
No, but I might have a 3D printed copy of myself that would like to go up there for field testing sometime soon. No,
That's pretty awesome.
Amazing.
No, just to kind of characterize that, I've had the privilege of working with incredible folks from NASA, from academia, just different levels of industry and governance that taught me what ISRU really is. So in theory, obviously you guys know what it is, but the principle of taking any kind of locally derived material and utilizing it for a variety of different purposes. It doesn't just have to be 3D printing infrastructure. It can be mining. It can be resource extraction of things like helium-3, oxygen, or water from the water ice in the South Pole. It's pretty wide-ranging what's available. And to categorize that further, what we do at Space Copy is we are working with as much of the raw material as possible. We filter out things that would be harmful to the 3D printing process, like oxides, because, well, if you're heating up regolith, it's going to release oxides, kind of like oxygen that has not been fully processed into oxygen yet. We have to separate that particulate away from our system, because the second you get oxygen in a 3D printer, all your parts are going to start cracking. My foray into ISRU has been very, very heavy, diving in headfirst into subject matter. When we're looking at the composition of lunar regolith, we're seeing maybe at least in the South Pole, where the next Artemis landing sites are planned for, we're seeing like 10 to 12% metal compositions of titaniums and aluminums, 1% quartz, 48% silicon dioxide. It's really helpful for us because it gives us an understanding of what parameters we're working with. Silicon dioxide, for example, is very much related to ceramics. Ceramics manufacturing has been around for 4 decades, so we can take and pinpoint a lot of data from things that are coming from, for example, Chang'e 5. And they did the autonomous scan of the lunar South Pole, and just kind of...
That was the Chinese mission, right?
It was, yeah. I believe it was a multidisciplinary effort, actually, but it was mostly pioneered by them. But data was released publicly, and we were able to pull some of that data and say, okay, if this is what the South Pole is made of, and this is where our Artemis astronauts are going, this is where we're landing our 3D printers, what do we have to take into consideration here in order to make this work? And the more you start to talk to people that are in either physics or geology for the lunar surface, the more you're going to get into very, very spirited debate about what is right and what is wrong for assumptions on ISRU. What we do is we work with different laboratories globally, but mostly in the United States, to create our own custom lunar regolith simulants. So try to model as close as humanly possible to what's going to be found on the moon, so that when we're doing 3D printing tests, we're generating something that's high accuracy.
Interesting.
What would you say it's comparable to on Earth? If you were to say what lunar regolith was like here and the construction of it, what would it be like? Would it be heavy? Would it be light?
I'd say probably more on the light side, or at least we break it down into such fine particles that it is light. I have definitely ran my hands through some big pits of regolith or some big bowls of it just to try and get a feel from a mechanical point of view. Regolith is angular, it's not round, it's like working with glass that happens to have the properties of metals and ceramics kind of grouped into each other. So it's not a fun thing to work with. It sticks to everything. And the second that you have that static cling getting stuck to stuff, your mission is over. It's going to get into the joints of your machine. It's going to break stuff down. It's going to scrape everything. Things are going to get wrecked. The way that we try to simulate it, at least to the best of our ability, we take a lot of minerals and resources from different mines. Actually, a lot of the regolith simulant that's sold worldwide is produced in Canada. I don't think many people know about that. Yeah, the mining industry in Canada.
I didn't know about that.
Yeah, we're not just mining for oil and gas. We're mining for simulated lunar dirt as well. I know that's not a straight across the board answer, but we have so many resources at our hands when we're trying to simulate ice or related conditions that I think it's a really interesting subject matter.
All right.
That's so cool. What do you find really cool about space or working in space or living in space?
Do I have to pick one thing?
Top three, top five?
Okay, let's do top three.
Okay.
I talked a little bit about it during our thread of discussion, but I think just not knowing all the answers and diving into an ecosystem where you get to be novel, you get to try new things. The second component of that, which I think kind of ties into my first sub-answer, would be the fact that there are certain things that work better in space than they do on Earth. Even some types of manufacturing, you're more readily able to conduct these experiments in space because the lack of gravity, or at least the reduced gravity effects, can have even greater impacts on the longevity of certain things that are being manufactured or produced in space. And that's everything from pharmaceuticals to manufacturing and everything in between. And then last top three item, besides the fact that it's just a really cool field to work in, and the second that you come up to somebody and say, hi, I'm building 3D printers for the moon, and their eyes get much, much bigger. I'd say it's just kind of being able to translate the importance of living in space to our everyday lives here on Earth. I mean, there's so many critical components of technology, not just GPS, but everything from just so many different types of technology. I couldn't even name all of the ones that I probably want to talk about, but things that were designed for space that came back to Earth.
And, you mentioned, technology developed for space on Earth. And I think it was season 1, episode 1, where we talked about Uber. And Uber really being, with its requirement of GPS, being a space technology. Without space technology, Uber doesn't exist. And it was, I think there's a Calgarian on, I think the first 8 employees in Uber as well. So we have that connection to these companies.
That's awesome. Yeah, I actually think I did a study on Uber when I was in my earlier days of business school at Harvard. And I was thinking to myself about GPS and telecommunications, all different companies that use it. And I didn't think of it initially, but I came back to it afterwards and thought about, we wouldn't be doing half of the stuff that we're doing right now as a species. Space is necessary.
Well, you're an Alberta success story. I'm just going to put that out there. Like, it's pretty incredible what you've been able to accomplish, and especially in Edmonton. That's awesome. How has it been working on an international level for you?
I love working on international level. The great thing about space is that it's a global community. Everybody knows everybody, which is fantastic, because the more that you start to talk with people, the more that you get introduced to the next person down the line who is doing something that's really interesting and possibly related to your research. Aside from that, though, being from Alberta and then stepping onto the global stage, not a whole lot of people know where Alberta even is. And you just say, oh, it's Western Canada. Is it Vancouver? No, it's not that far west. So it's really interesting to talk to people and, share with them that there is a space community in Alberta. It's small, but it's strong. The talent is here. There are some resources here. But having the opportunity to go international with the technology. I mean, we started this company in Saudi Arabia, and we brought the technology back to North America. We're going through an acceleration program with venture capital firm Techstars. And then we went to international incubators in Singapore. We have traveled the globe. We've been to conferences across Europe, like Italy and France and the UK. I know this past October, Space Copy and myself, we were honored for the 75th anniversary of the Commonwealth. We were invited to Westminster Abbey. We were featured in a book publication that was written by the King's biographer to talk about the importance of science and the importance of Canada's positioning of science as a global nation, and being an Albertan, having the chance to represent that was really, really meaningful. I have a huge respect to everybody that works so hard and every day, whether it's in space tech or whether it's in entrepreneurship, especially in Canada. We are not as small when it comes to our footprint in space, but we're not necessarily one of the top powers. We are not NASA. We are not the European Space Agency.
Right.
Having the opportunity to really bring attention to what we're doing, I think, is one of the more rewarding things about being from Alberta and being in space.
So you have a lot of experience, working in space, working with people. In this season, we were talking to some students and some university students. What advice would you give them as they're completing their studies, looking into the industry, hopefully trying to stay in Alberta, maybe going abroad? What do you tell students about entering the space industry?
I always let them lead with the subject matter. I do a lot of consulting work. I mentor for Concordia University down in Montreal. I always sit down with students that are interested in pursuing STEM or space-related careers and ask them kind of, what are your pain points? What are your bottlenecks? If you could be in this industry, what would you like to be doing? There's so many different nuanced answers. People talk about robotics, they talk about space medicine, they talk about being an astronaut. And then I really kind of just break it down with them and say, okay, how do you think that you could achieve that goal? What are you working on right now that's helping to further that position, that aspect? And what do you feel that you could be doing better or that you need more help in order to be able to achieve that goal? And the more that you have conversations like that and really just dive into people specifically, don't just give them band-aid advice, sign up for the NASA Lunar Surface Innovation Consortium, which you should, by the way. But if you have another area of space that you're really looking to pursue, there are tangible action items. There's resource committees. There's huge communities in Alberta, in Canada, and on a global scale that people can continue to be part of. I struggle with the fact that there is brain drain from there's not an abundance of resources. We don't have an aerospace engineering program at any Alberta university, for example. I believe that you can build a career for space in Alberta. I think that we are a primary example of that. That said, we still do a lot of our work outside of Alberta as well. It takes a village. It's a cross-disciplinary effort. And definitely when I sit down, I do consulting for students. My main kind of message that I want to send to them is that it's possible. You're not too early, you're not too late. You don't have to have that one-size-fits-all narrative in order to contribute to the ecosystem. And there are places for space right here in your own hometown if you want to look for it. And I think that the stronger that we kind of repeat that message and make it more resilient, the better off that we're going to be creating a more localized ecosystem so that there is an even stronger momentum for keeping Space Alberta strong.
Well, that is exactly what we're doing here today, isn't it?
And that's what we started this podcast for. We really have talked to so many people from different backgrounds. There's just so many different types of jobs in the space industry. And I think we've been lucky enough to talk to so many Albertans that, are on that wide spectrum. You're traveling, you're pitching your ideas, you're going through the motions as an entrepreneur. What is next for Space Copy? What do you still need support with?
Oh, there is plenty of support needed to put 3D printers on the moon. So I talked in the beginning of our conversation, we're sending our first 3D printer to the Arctic next year for field testing. But more than that, we're also hoping to get a very small, kind of CubeSat-sized 3D printer that we're building out into space at the end of 2026.
So is that like how big is this CubeSat again? It's like this big? How big is a CubeSat?
It varies in size, but yeah, you nailed it. It's like
Yay.
the smallest it could be is probably about 36 centimeters cubed. And then if we have, a larger opportunity to hop on a slightly larger satellite bus, and we can maybe look at, 45 centimeters, 60 centimeters in diameter. So it's super small. You're not going to print anything beyond a wrench. But
we're talking toaster, maybe microwave size here.
Yeah, a big toaster, a big fat toaster.
I like my bread. I've got the industrial toaster.
3D printing toaster. Is that what it's going to look like?
Just pops right out.
3D printing a wrench.
Have your bread and print it too. So
Ooh.
Okay, you get to credit us if that's your new marketing slogan.
yes, and we can engrave the word space copy on it, and you can use it for all of your public advertising. Keep it in the background.
Amazing.
Aside from that, though, no, we have great missions in our pipeline for 2026, 2027 onwards. So yeah, Arctic mission and space mission are next on the horizon. Just get us into some relevant ecosystems where we can start testing out like the space-based radiation, the microgravity, the extreme cold in the Arctic. We're a company that is still relatively young. We've been around for 3 years now. We're fundraising. We're trying to recruit more talent into the mission. We have summer programs for internships. We have winter programs for internships. At this particular moment, we have 42 research interns with us on the team. A good chunk of which are here in Alberta, by the way, which
amazing.
But a lot of them are Canada-wide, a lot of them are international. We have giving back programs to get more underrepresented youths and early career professionals into the industry. So we even have people from places like Kenya and Uganda that are being trained into 3D printing for space that can come into our program. And then on the kind of larger like industry, government, private capital side of things, funding the next build, getting the next MVP into development, getting that prototype out into the ecosystem. We don't have all the answers. Nobody does. Nobody has ever done this before. We are breaking ground.
Scary.
And it is. It's somewhat terrifying, but I do love a good challenge, and so does our team. And we have decided that we're going to dedicate our lifetimes to setting the precedent for the global future of space. And we can really only do that by doing things that people haven't done before. And we look at critical technology gaps from NASA. We look at the top 20 technology pieces that were actually named by the administration of things that we need to go back to the moon. 3D printing was on that list. ISRU was on that list. We have combined both of those efforts. And now the final phase of that is just really looking technically at what are the challenges. If you're 3D printing in vacuum versus inert conditions, what are some of the parameters that you have to look at? If you're 3D printing with one type of lunar regolith versus another, or you're switching over between a ceramic base and a metal base, how is that going to impact your printer system? There's just all these different nuances that I think people don't really think about until you're in the laboratory and realizing, oh my gosh, what did I sign myself up for here? Because nobody knows this answer, and now it's up to us.
What would be the most ideal thing for you personally to be able to build on the moon?
The most ideal thing? Gosh, besides actually having like astronauts and infrastructure on the ground a little bit already, so that we have that reassurance that if we can't get the power button to start from our computers on Earth, that an astronaut can go walk up there and hit the start button for us.
Right.
I mean, from an architecture point of view, yes, that's the end game, right? That is the sweet spot where you have a little bit of prerequisite, just enough to get the job done. I think it would be great to have some kind of modular deployable shelter for the 3D printer initially. I mean, it's meant to work outside, but that's also going to contribute to the wear and tear if it's being consistently exposed to radiation and lunar dust. So looking at mitigation strategies before we get to the surface, I think would be something in my arsenal that I'd really like to have. And then from the parallel side of that, something that I think would really help us in the here and the now, because we're talking about something that might not go to the lunar surface for 5 years, but we're still going to be building out this technology for our immediate clientele that is in extreme Earth environments or even in low Earth orbit. I think that is the golden opportunity of early stage space companies to really get to know what are the challenges of what they're working with, not just from a product point of view, but from a technical point of view, from a business development point of view, and just kind of tying all those different threads together.
That is an extremely responsible answer. Megan, when you asked that question, all I could think about was printing a giant ramp so I could ride like the moon rover off and fly through the sky in low gravity. That would be what I would build. Yours is actually a solid business plan. Mine is just funny. So,
Mine would probably be a toaster.
A toaster? Get that space toast in? Madison, I think we've heard a lot about your company and what you're doing, and we have a segment on our show here that we do, book club here. We're going to don our book club hats for book club here. And we asked this question to kind of get to know you a little bit, and our listeners can read the same book to kind of get an understanding of where you're at. What book did you bring today for our book club?
Ooh, I brought a couple. I hope that's okay.
Okay.
I have an astronaut helmet somewhere back here. I could go find that so that I'm not the only one in the no hats group.
As every good person does, they have an astronaut helmet in there,
Of course.
at arm's reach. Yes.
Yeah, no, like you can't be in the space industry and not go visit a NASA center and hit up the gift shop. I recall the last time I was at Kennedy Space Center and I was being taken around by one of my engineering friends I used to work with there, and I basically had to buy another suitcase just to take all of the stuff home from the NASA gift shop. And yeah, he got a good laugh at looking at all the different stuff that I was hauling out of the NASA center grounds, arms full of bags. To answer your question,
Yep.
on the book, I'm going to give you one about space and I'm going to give you one about entrepreneurship.
Perfect.
On the entrepreneurship side, something that I read in the first month of incorporating my company was The Mom Test by Rob Fitzpatrick. And that book really fundamentally changed the way that I was looking at starting a business. It's not just about people pleasing. It's not just about having, nice smiling faces as you're engaging with people. I mean, smiles, have a nice and productive conversation, but really just getting to the bottom of how to talk with people, partners, customers, and really understand when are they saying something that might not be fully authentic? And are you properly reading between the lines of what they're saying? Are they really talking about something that's useful for you? Or is it just something that you want to hear? Is this something that would help them as you're having a conversation? Is it rewarding to both parties? So the Mom Test, highly recommend it. It's not even a huge book to read through. I think that if you actually sat down with it for a few hours, you could get through it in a couple days. And
That
I
sounds
recommend anybody.
perfect.
It doesn't matter if you're in space or not. Anybody that is in business and entrepreneurship, or anybody that deals with sales and customers and just people in general, the Mom Test, I think, is a really good and powerful book.
Yeah, a lot of our guests have talked about these books that say they've helped me in my space ventures, but helped me as a person as well. These are just helpful things to be a better human being.
100%, 100%. So that's my entrepreneurship book. I would also love to share a space-related book, and
Please do.
not the one that I'm writing right now, but one that I'm working on, kind of piling through. I'm in the early stages of reading it. It's called The Moon Builders by a fellow geophysicist friend of mine, Roberto Moraz. And it is the most technical subject matter discussion about
So
ISRU.
it's a textbook.
It could pass for one. I'll give you that. It is meant to be like a nonfiction science-related novel,
Okay.
but is very, very much in depth. It's talking about geotechnical versus physical versus mechanical characteristics of regolith and how that plays into ISRU, mining and manufacturing for space. And I remember talking to Roberto about this when he was just like developing out the early manuscript for this. And I remember being just absolutely mesmerized by some of the stuff that he said. I consider some of his words to be great advances in the field, but also great on the mentorship perspective for myself personally and for the company. And I was so excited when he dropped me a note saying that the book was released. And so I jumped to Amazon, got it into the cart, and now I'm starting to dive into the earlier chapters about understanding the composition of the moon and how ISRU plays into the larger framework of necessitating the journey back to space. So if you're wanting to space nerd out a little bit, if you want to dive into really, really complex subject matter, The Moon Builders is the way to go.
Did you say that you were writing a book? Did you slip that in there at the beginning of this?
Haha, you did catch that. Yeah. I've done a lot of writing. Most of it is fiction related and not at all related to space. But I am also working on just compiling some of my generalized knowledge into what it takes to be a space entrepreneur and seeing if I can put together a framework. A lot of it was done internally for myself in order to keep accountable and really just hone back in on the lessons that I learned in my early days and make sure that I was recognizant as a founder and passing and disseminating that knowledge on to the rest of our team, so that we were building smarter, not harder. It has somewhat evolved into a running storyline about what are the challenges of entering this industry and how to navigate them effectively. So it's very much an in-progress effort, but it is something that I work on in my very, very small amounts of spare time.
Well, it sounds like we have a season 2 book club early entry, or season 3 early book club entry there. We'll have to get that on the list. That is exciting.
That's amazing. Those are great books. Thank you so much.
Yeah, absolutely.
We're at the part of our episode where we have questions that we brought from our social media followers that come to us, that we now have social media followers that ask us questions.
Yeah, it's
Season
called,
2,
it's
which is
called
amazing.
it's called Ask a Space Question.
So through the magic of editing, I'm going to switch spots with our question asker, and we are going to...
You can come over here, actually.
Yeah, come on over here.
Take my spot. It's probably easier.
And take this spot.
Hello.
Why has Sandra Lynn got a better outfit than I do?
Oh, right. Hang on.
Awesome.
Hi.
Hi, good to see you.
Oh my God, it's so nice to hear you. Okay. So, today's question comes to us as a video message on Instagram from Bethany.
Hi, my name is Bethany Doucette, and I'm from Calgary, Alberta. Who was the first woman in space?
Oh, and there have been many. I cannot remember the year of it exactly, but it was a Valentina Tereshkova who was a...
Bingo! You got it. Good job.
Awesome. Thank you.
Fun fact. Yes, she was the first woman to fly to space. She was a Soviet cosmonaut and engineer to fly to space on Vostok 6 mission in June 16, 1963. She spent almost 3 days in space, orbiting the Earth 48 times in her space capsule, Vostok 6.
I remember, Madison, I'm putting you on the spot here. I believe the first American was Sally Ride, if I'm not mistaken.
I am 99% sure that you're correct, yes.
I'll take that as yes. And then the first Canadian would have been Roberta Bondar, if I'm got up
Yes,
on my facts.
that
I didn't Google any things before that by
Canadian
accident.
woman,
Yeah.
yes.
That's who
Yes.
I was thinking of when you first asked that question. Then I thought, yeah, no, it's international.
No,
Yeah.
you know this. Yeah. Cool,
Awesome.
cool.
Yeah, there's been some really powerful women in space, even to this present day.
Absolutely. All right, now through the power of editing, we're going to whisk Megan back into the to the studio here. Well, Madison, thank you so much for taking the time to speak with us. It was, I don't even have the words for it. Do you have any words for how this interview went? Inspiring?
I have no
motivating?
words. I think I
was,
blacked out.
It was
I'm
amazing.
just kidding.
Out of this world.
Out of this world.
And I was also thinking about another joke. So we start our episodes off with a joke, just because this is
We're
it's
fun-
part
we're
of our
funny
gag.
people.
It's part of our gag. But I'm like, I don't want it to be a joke. I want it to be like a quote. But you are definitely making an impact, like an asteroid would in the space world. But not
we'll workshop
dangerous.
that
Anyways,
one. Yeah,
we
we're
gotta
not saying that
workshop
you're a
it.
planet-killing entity at all.
I'm going to cut that out completely. But all I can say is that it's been a complete pleasure chatting with you, because you are not only pioneering in the 3D printing world and thinking about space, but you're just such an inspiration to so many people, especially in Alberta, young women who can see themselves doing what you're doing. So thank you so much
I
for
think
being
you're an
a part of today's
inspiration to
episode.
us. I say that. That is, I feel inspired. Do you feel inspired?
I feel inspired.
Team, do you guys feel inspired? We got hands up all across the board
Thumbs up.
behind the cameras there.
I'm so happy to hear that. I want to say thank you so very much for having me, for engaging in such a dynamic discussion, and for being part of the greater Alberta space movement to bring more attention to the fantastic people that are making waves in this industry. It's a privilege. Thank you so much.
Oh my
Thank you.
gosh, thank you so much.
We
That
can't
was
wait
such a nice...
to catch up on season 3 when you've been printing and have a book to share with us for a book club. It's going to be so exciting.
You can count on it. Thank you so much again.
We would like to thank Madison for joining us today and telling us all about Space Copy and the future of economical and sustainable construction here on Earth and in space with 3D printers.
If you'd like to keep up to date on Madison Feehan and Space Copy team, please check out the website, spacecopy.com. They're on Instagram at Space Copy Official, and also on LinkedIn and YouTube.
Shout out to Sandra Lynn for her writing and research efforts, Matt Waterworth, our sound and video engineer at No Cap Content Studios, his assistant Parth Kelkar, 6 Degrees Music and Sound, and Kristen, our behind-the-scenes photographer, for helping us make this podcast sound and look amazing.
On the next episode of Albertans in Space, we speak with Jim Ellis and Noreen Humble, U of C alumni and professors, and the authors of Mythologies of Outer Space,
which we'll talk about in the episode. Thank you so much for watching Albertans in Space. We hope you enjoyed today's episode. Make sure to tune into our socials to watch behind-the-scenes content and exclusive content. You can watch Albertans in Space on TELUS Optic TV, Stream Plus, and our YouTube channel. For those that prefer listening, catch us on Spotify. If you like the show, don't forget to hit subscribe and give us a like. Your support means the world to us. Lastly, stay connected, follow and say hi to us on Instagram at AlbertansInSpace_podcast and on TikTok at Albertans in Space.
Thanks so much for listening, and we'll see you next time. Bye.